Today we look at further complex numbers, focusing on de Moivre's theorem and the roots of unity. De Moivre's theorem tells us something simple. When you raise a complex number to a power, you multiply its angle by that power. At the same time, you raise its length to that same power. In symbols, this is written as the quantity r times open bracket cosine theta plus I sine theta close bracket, all raised to the power n equals r to the n times open bracket cosine of n theta plus I sine of n theta close bracket. The nth roots of unity are a special set of n complex numbers. They all sit evenly spaced around a circle of radius 1 centered at the origin. Each root can be found using a formula. The kth root equals cosine of 2 pi k divided by n plus I sine of 2 pi k divided by n, where k takes the whole number values 0, 1, 2 up to n minus 1. Let's work through an example. We will raise the complex number 1 plus I to the power 4 using de Moivre's theorem. First, we find the modulus of 1 plus I. The modulus is the square root of 1 squared plus 1 squared, which is the square root of 2. Next, we find the argument of 1 plus I. Since the real part and the imaginary part are both equal to 1, the argument is pi divided by 4. Now we apply de Moivre's theorem. Raising 1 plus I to the power 4 means raising the modulus, square root of 2 to the power 4, and multiplying the argument, pi divided by 4, by 4. The modulus square root of 2 raised to the power 4 equals 4. The angle pi divided by 4 multiplied by 4 equals pi. So 1 plus I to the power 4 equals 4 times open bracket cosine of pi plus I sine of pi close bracket. Since cosine of pi equals negative 1 and sine of pi equals 0, this simplifies to 4 times negative 1, which is negative 4. On the Argand diagram, we can see 1 plus I as a point above and to the right of the origin. When we raise it to the power 4, the point rotates around to the negative real axis and stretches outward, landing exactly on negative 4. Now watch the same picture lift into 3 dimensions. The flat Argand plane becomes the base of a spiral. As the power increases from 1 to 4, the point climbs upward along the spiral, turning through angle pi by 4 each step, until it reaches the top point directly above negative 4. Let's check this answer directly. 1 plus I squared equals 1 plus 2 I plus I squared, which is 1 plus 2 I minus 1, giving 2I. Squaring again, 2I squared equals 4 times I squared, which is 4 times negative 1, giving negative 4. This matches our earlier answer, so the calculation is confirmed correct. Now let's find the nth roots of unity for a small value of n. We will use n equals 4. Using our formula, each root equals cosine of 2 pi k divided by 4 plus I sine of 2 pi k divided by 4 for k equals 0, 1, 2, and 3. For k equals 0, the angle is 0. Cosine of 0 is 1 and sine of 0 is 0, so this root is simply 1. For k equals 1, the angle is pi divided by 2. Cosine of pi divided by 2 is 0, and sine of pi divided by 2 is 1, so this root is I. For k equals 2, the angle is pi. Cosine of pi is negative 1, and sine of pi is 0, so this root is negative 1. For k equals 3, the angle is 3 pi divided by 2. Cosine of 3 pi divided by 2 is 0, and sine of 3 pi divided by 2 is negative 1, so this root is negative I. Plotting these 4 roots on the Argand diagram, we see 1, I, negative 1, and negative I, sitting at the 4 compass points of a circle with radius 1. Now watch this circle lift into 3 dimensions. Each root rises to its own height along a cylinder, showing the same 4 points now spread evenly around the curved surface, still keeping their equal spacing. To check these roots are correct, we confirm they are evenly spaced. The angle from 1 to I is pi divided by 2. The angle from I to negative 1 is also pi divided by 2. The angle from negative 1 to negative I is again pi divided by 2. And the angle from negative I back round to 1 completes the circle, also equal to pi divided by 2. Since every neighbouring pair is separated by exactly the same angle, pi divided by 2, The 4 points are confirmed to be evenly spaced around the circle, exactly as the theory predicts.